Do you ever wonder why things fall over? Well, in order to see why things topple or fall, what we need to do is talk about a property of all objects called the center of gravity. Now, what is the center of gravity? Center of gravity is an imaginary point in all objects where all the mass or the weight appears to be concentrated. Now, that can be in the mass itself, or it can be in space. For example, if I have a cube and I were to take the diagonals of all the cubes, corners to corner, what I would do, I would find that there would be a center where all those diagonal lines crossed. And the point where they intersect is called the center of gravity. And all objects have this. Some are in the substance and some aren't, as I said. For example, where is the center of gravity of a tire? Well, it's right at the center of the circle that would have made that tire if we took a look at it as a plane. Or where's the center of mass between the sun and the moon? Or the sun and the earth? Well, it's not either in the earth or in the moon or in the sun. It's someplace between us. But we know that if we look at the center of gravity is the key to why all things are in balance. If we take, for example, a basketball and we roll it around, it doesn't seem to be any more stable or unstable than it was in any other position. And that's because, for one reason, the center of mass, which is at the center of the basketball, because it's a sphere, is always the same height from the support system, from the table or the pavement or whatever you have it. And because the center of gravity can't change its height, it will always be in what we call neutral stability. And it's probably the most stable of all substances are spheres, or anything that keeps its center of gravity at the same height. Now, the key to keeping something stable is to making sure that that center of gravity, wherever it is always over the support system, or what we call its baseline. For example, I can take a meter stick and I can balance it from the tip of my finger, and if I'm good enough, I can keep the meter stick staying there for a while. But eventually, my hand will get tired, the meter stick will fall, and that's because the baseline is very small. And in the meter stick, the 50 centimeter mark is pretty high compared to the baseline. So, in this case, we have something that is stable because its center of gravity is directly over its baseline, but there's not a lot of wiggle room. So in this case, the stability is mezza. It doesn't take much to push on it, and it'll fall to a lower level. Now, if you want to make something more stable, what you do is you either increase the size of the baseline, or you lower the center of gravity. And as you lower the center of gravity and increase the baseline, you get a more stable substance. It's only when you get some things that the center of gravity now goes beyond this baseline, then the object does what we call fall or topple, because the center of gravity always wants to be at its lowest state. For example, there was a lot of money put into the Leaning Tower of Pisa in the last few years. It's a historical site, and it's also a national treasure to the people in Pisa in Italy, but it was bending. And if you were to take a plumb line from the center of gravity and drop it so it went straight down, it was getting pretty close to the point where at some point, if we weren't careful enough, the Leaning Tower would have no other choice to do but to topple and fall down. So how did they fix it? Well, they fixed it by trying to lower the center of gravity and by shoring it up with more steel girders inside and trying to make the center of gravity as low as they could bring it, in which case they did. And they increased the baseline, and now the center of gravity is lower than it was before, and the Tower of Pisa is now still stable. Well, why did it become unstable? Well, all things put pressure on the ground. Its weight, gravity pulling it down, will shift the soil below it. And so therefore, everything shifts or settles after a while. And when it did, that's what caused the tower to tilt in the first place. The ground settled underneath the tower. Now, you often see this happen. You're riding along a turnpike or a highway and you see these big giant tractor trailer, 18-wheeler trucks, and they're laying on their side, particularly when they're going around the curve. And let's see why. As we said, the baseline is necessary to be broad enough so that when something tilts, that center of gravity will still keep that truck or that object on its baseline. Now, if there's a big wind comes, or if you're getting around the curve, the center of gravity's plumb line will now shift, and as soon as that center of gravity goes beyond the baseline, the truck can do nothing else but fall over. It's natural.